I have a second channel, Cube Comp MTDX. Hey everybody, next I'm going to be testing out these purple cells I pulled from this generic replacement laptop battery. It came out of a older Dell Latitude laptop. I have no idea of the age of this replacement pack, so I don't know exactly how old these cells are, but they are, all six of them are sitting at about the same voltage, although they are at kind of a low voltage. But that's not exactly a bad thing in this case. As I finished up the previous video when I harvested these cells, I mentioned, I believe I mentioned about in the case where you have, let's say, one pair of cells sitting at like 2 volts and the remaining 4 sitting at, I don't know, 3.5, 3.6. Usually I would say in that case I wouldn't bother with the low voltage cells, but in this scenario all 6 of them are sitting at around the 2 volt range. So although they're sitting at low voltage, they are pretty well in balance with each other. And some of my decent cells that I have harvested were sitting at a low voltage like that because they've been sitting for a while, and the with time, this little circuit board that monitors the pack and balance charges it and what have you, this can actually drain down the cells. So yeah, it's not that the cells themselves had drained down. It's really part of it. I think a good portion would be blamed for this little guy. So what we're going to do is we're going to go ahead and charge these up. We're going to start them out though at a low current because they're sitting at a pretty low voltage. Now this charger is actually really good at waking up cells that are sitting with a low voltage. What it will do is it will ease back the current no matter what you have the current set to. Even though the minimum setting is 200 milliamps, in the case that the cells are sitting at a super low voltage, it will automatically adjust the voltage downward. No, excuse me, the current downward until the voltage comes up. Now watch this. We'll see if it does it here. So we'll pop all these in. And you can see they're all sitting. These are sitting at. Those are sitting at like 2.8, and these are like 1.98. But we'll just see what happens here. I'll put these in. Put these in when you see the numbers. You can see how it's adjusted the current down on these two because they were sitting at a low voltage. These two it has not because they're already at a decent voltage. You can see how it is gradually increasing the current. Just keep a feel on the cells, make sure they're not getting warm. You'll see how it's going to adjust the current around until the voltage comes up. Now these were already, what was it, 2.8, 2.7? So those two were okay as it was. And what it's going to do is it's going to gradually bring up the voltage. You see it's already up to 200, or 230 actually. And this will generally take a few minutes, and these are already rising up too a little bit. And of course these lithiums, they don't like being below, they generally don't like being below 3 volts. You can see how these are, they're quickly waking up. The voltage will typically rise really quick. And the reason why the charger starts out with really low current is when you have cells that are holding a low voltage. If you force a lot of current through them, in that case, you could really damage them. They could actually short out. So what the charger does, it knows that the voltage is too low to push through the specified current, so it automatically adjusts the current down until the voltage comes up, and then once the voltage comes up, it can, of course, raise the current. And of course, these are up to 3.05 and 3.04. These are working their way up. And once these two here get up to just around 3 volts, I'll then increase the charge current to 1 amp. And what we'll do is we'll charge these up. And I'll keep a monitor on them, keep an eye out, make sure they're not getting hot. And if they charge successfully, I'll discharge them and see what I get out of them. I'll discharge them at 1 amp, and I'll see what kind of capacity I get out of them. And once I complete that, I'll charge them back up, and then I'll have to let them sit for a while and see how well they hold their full charge voltage. Because of course, healthy lithium-ion cells have very low self-discharge. So we're getting really close to the 3 volt mark on these two. These will be a little ahead, as you can see they're up to about 3.1 now. Okay, so we're ready to go in and adjust the charge current. Actually, before I do anything else, I'm just going to go and do a quick test. I should have done this, but well, I'm not sure how accurate this quick test will be with such low voltage on the cell. So since we're at 3 volts now, we'll go ahead and do a quick test. These numbers ain't too bad. This is internal resistance in milliohms. So 100 to 98 to 115. And as I've mentioned in previous videos, this charger, sometimes if you don't have these sliders right up against the cell, it'll give you a little bit higher numbers. But these cells seem okay. I consider I consider the low 100s to below that to be a decent internal resistance. Now, when you start getting over 200 or 300, that's when you're really starting to notice some problems, especially if you're pulling any significant current out of the cells. Now, these are not high draw cells. These are typically like these laptop harvests. They usually can only pull up to 2 times the capacity. So, let's say these are 2200 milliamp hour cells. You can only pull they're rated for a max current draw of 4.4 amps. Okay, so that being said, we're going to go ahead and go back to charge. And we'll increase the current to 1 amp. And we'll charge them up. And if anything crazy happens or there's any updates, I will definitely include them in this video. Okay, everybody, so these 4 cells have charged up, and have a look at this. That's how long it took to put a charge in them. That's your first sign. That's the resting voltage. They just finished not long ago. Look at these numbers. Around 2200 milliamp hours is what these things took, and they didn't get warm at all. So, to my opinion, that would be very little power was wasted as heat, obviously. So, we're going to find out what these cells have in them in a discharge cycle here in a sec. So it looks like these might practically be the equivalent of new cells. Sometimes you get lucky with laptop batteries in this case. You may come across a pack that didn't get that many cycles on it, or just simply didn't get that much use, and the pack with time just drifted into discharge to the point where the control circuit was like, okay, we're going to reject this pack. And in that case, the cells usually can just be woken back up, and bam, you got good cells. And I think we might have an idea of when these were made. At least the pack, this little circuit board in here has a revision date of January 14th, 2010. So that is some sort of clue as to the manufacture date. So we're pretty certain that the cells are not older than 2010. Probably from 2010 to 2012, if I were to really guess. Alright, so we're going to do a discharge. At 1 amp, and we'll see how well these do in a discharge cycle. Okay, everybody, so the discharge cycle has completed, and here are the resting voltages. You can see around 3.3 to 3.4 this cell here. We'll have a look at this. 2104, 2129, 2063, and 2079. Those are not bad numbers. That was a discharge cycle at 1 amp. So I'd say that's pretty good actually. So we're going to charge these back up, and I should mention they stayed cool the whole time. So these are practically like brand new cells in a way. So we're going to charge these back up, and I'll repeat the same steps for these two here. And I'm pretty confident these will hold a voltage, and we'll find out for sure once they fully charge. So let's go ahead and go back into charge mode. Charge them back up. Okay, everybody, they just got finished charging. That's what went into them. That's how long it took. And these are the resting voltages. This one here just finished like 15 seconds ago. And the other three, they finished earlier. So number 3 was the first to finish. Followed by these two, and then this one. Let's cycle back around to the capacity. So yeah, that's what went into them. So yeah, very impressive. These 4 cells, they're doing great. I'd say they're doing pretty good considering what they're rated for. And what's also interesting is this generic laptop battery pack, the cells pretty much met what was on the sticker. So again, when you factor in everything, the cells should have been 22 milliamp hours, and they seem to be practically just that. Maybe a little less because of age, but that's not bad at all. So next I'll be performing the same steps on number 5 and number 6. Okay, so now I'm going to repeat the steps for cells 5 and 6. Go ahead and pop them in there. Set the current down low, because they were sitting at 2.44 volts. And the voltage will work its way up to 3 volts, and once it does, I will increase the current to 1 amp per cell. And once they get up to 3 volts off, first I'll actually do a resistance check. Cells aren't getting warm at all, they're staying good and cool. That's good. It usually doesn't take the cells very long to get to 3 volts. This is another phrase for well, the common phrase for this is waking the cells up. And so we're right around 3 volts. Once this one here gets up to 3 volts, we'll go ahead and stop and do a resistance check. Okay. So 101 and 105 milliohms. And we'll go back over to charge. And we'll charge them at 1 amp. And since I've also got some other cells I need to charge, I'm going to pop them on there as well. Okay, so these cells are charging up, and I got these two over here charging as well. Now off camera I did a resistance check on these, and these are measuring like 195, 196 milliohms. So these are, like I say, these cells for their age, they're still doing really well. I think. These are the cells I use in my weather case storm cams over on QComp MDDX, and for longer run times I'll pop in these Panasonic NCR 18650Bs, which these have been rewrapped. This is what the original ones look like. Yeah, these are 3400 milliamp hour cells, and the resistance on these is still, I think, below 100 milliohms. So these are the these NCR 18650Bs. They're the only off-the-shelf 18650s I have. The rest of my 18650s are laptop harvests. So we'll let these charge up and we'll see how they do. Okay, everybody. So these cells have charged up. They took, well, there's your resting voltage, and also the Sony's over here. You can see they had the same resting voltage. That's how much they took altogether, 2200 roughly. Now the Sony's, I think as I may have mentioned, the Sony's weren't fully drained. So we're going to take the Sony's out. And I'm going to go ahead and discharge these and see what we get out of them. And I got these other two Sony's I need to charge up, so I'll go ahead and stick them on. You know, the thing about this charger, you can do multiple things with it at the same time. If you want to discharge a couple of cells and charge another couple of cells, you can do it. So these cells, they've come down to 4.04 and 4.03. So we'll let this run its course and see what we draw out of them with a 1 amp load. Okay, everybody, so cells 5 and 6 here have finished discharging, and look at these numbers. These are good. Cells didn't get warm at all. They done fantastic. So I think it's pretty safe to say these are 2200 milliamp hour cells. They just got a little bit of age on them, and they've probably lost some of the capacity due to sitting at a low voltage like they have for the past who knows how many years. The laptop that this pack came out of has just been sitting in my collection for a while, and I don't even remember where it came from. But it's been sitting like this for quite some time. So what we're going to do now is I'm going to take out these two cells since they're done charging, and we'll go ahead and charge up these other cells. And see what we get for capacity, or at least what we'll get for how much to put back into them. Just say that. And there's the voltage that they were at. And it's probably the voltage has already come up just a little bit. Okay, now No, take that back. That was the resting boards, because see, now they've jumped up a little bit since the charger started charging. So, again, as I mentioned, we'll let these charge up and see how much energy they take. Okay, everybody, these cells have finished charging. That's what they have on now. And that's how much energy went into them. So, what was it, 2075 and 2140. Not bad. Not bad at all. I would say these are fantastic cells. So, it brings me to a statement I want to make. You know, in the video that I shot recently of that nasty Dell laptop pack that had the made in China cells, yeah, I said, alright, Dell, that's what you get when you use China sourced cells. Not all China sourced cells are bad. You have good ones and you have bad ones. I've gotten some good ones and I've gotten some crappy ones too. For example, that 8-cell pack that I bought for my Red HP Pavilion Sleepbook back in, what was it, 2018? Yeah, that pack lasted me, what, a year and a half? And I think I harvested it in 2019 because 2 of the cells were already getting to be low voltage, and it wasn't the pack was out of balance, and the remaining cells ended up being heaters. I mean worse heaters than, say, like these Sanyos, for example. they were really bad. So I guess what I can say is a lot of the cells that had the 5 holes in the vent, these right here, I'd say I've had pretty good luck with them. I did have a pack a while back that was so drained down that the cells were practically near zero. Like this one here. That's why I got it actually. That's why I got the wrapping completely off of it, because it's drained to zero. I got it unwrapped, that way you can see what the actual cell looks like without the cell wrap or the washer on the top of it. So in the past I've harvested the well the cells are on my camera. I'm filming with right now, but it was a 6 of the 1900 milliamp hour cells made by the same company. They have the SZN and the ASO markings on them. Same company. Those have done really well. I mean, it seems like the only issue these cells seem to have is their longevity isn't quite as good as, let's say, name brand cells like Panasonic or Sony or LG or Samsung. These things, like for example, the 1900 milliamp hour cells I just referenced, I harvested those back in, I think, early 2018 or late 2017, sometime around then. Been using them for going on roughly 3 years or so, and while the resistance of them is still not bad, the capacity has dropped considerably. They're only charging up to like 1300 or 1400 milliamp hours. So it just seems like they don't hold up quite as well. Now, another thing is my Dell Inspiron 1525. I bought a replacement pack for it with generic cells in it back in early 2012, and that pack for all this time has worked pretty well, but it's getting to where it's not holding a charge really well anymore. I might crack it up and see what kind of cells we have in it. They're probably not getting recycled, but just out of curiosity, I may crack it open and see what's in it. But wouldn't be surprised if it was the cells with the 5 holes in the top. So I guess what I should say is, with laptop manufacturers mostly getting away from using packs on the externally mounted packs with 18650s, it seems that more and more often we may have to look for replacement packs that are out there for sales. Like for example, let's say a manufacturer makes sales for a given model laptop, and let's say that's an older model. Sometimes there could be situations where you'll have an overstock of these packs, and they sometimes will get sold for dirt cheap. That's one way to get sales for cheap. Sometimes you'll see these generic replacement packs going on eBay or Amazon for really cheap, and you can buy these things up and have you some somewhat decent sales. There's a YouTube channel. I think the guy's name is Richard Lloyd. He did this a while back. First he harvested sales from his HP's laptop battery, and there were LG sales. And he more or less said, okay, let's see what happens if I buy a brand new pack. And he bought 2 different brand new packs, and the manufacturer used a different source than this OEM for sales, but they were still pretty decent. So, I mean, you just look out there on YouTube. There's just so many videos of people harvesting these sales. It's crazy. So, anyways, enough of that. So it looks like I now finally have some decent sales. So that way I can retire these old LG cells that have a super high resistance. Let's do a voltage check of these other ones real quick, since I hadn't done so yet. See, look, 4.17 on number 1. 4.17 on number 2. So that's one thing we'd like to see is consistency. 4.16, that's still pretty close. 4.16. So cells 1 and 2 and the cells 3 and 4 are 2 different pairs. So yeah, these cells, yeah, it's safe to say these will be replacing these old LGs. You guys, let me just go and do it real quick before I end this video. Show you what the resistance is on these cells. Now these ain't too bad, but I think I had some that were pushing close to what, 300 milliohms of resistance. Let me try these other 2 here, just for example. These, matter of fact, the other 4 may as well. So yeah, I may test these one more time and see how they're doing. But with these numbers getting kind of high, I think it's time to go and recycle them. I think it's time to retire them. I harvested these. They came out of harvested them back in, I think, 2018. They came from a Toshiba pack. I think it was manufactured around 2011. So anyways, I think this about wraps it up. So that is the testing of these purple generic cells from that replacement pack for that Dell laptop. So I don't repeat myself. These will be going into my regular use for my cameras, like the one that's filming this video right now. So anyways, hope you enjoyed this video. Thanks for watching. Well everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.